Hello viewers, Kinematics question 3. A car is forced to stop at a red light. If it's travelling at 54 kilometers per hour and decelerates at 8 meters per second squared, find the distance it travels while stopping. So the first thing we need to do here is convert 54 kilometers per hour into meters per second. So we have 54 kilometers per hour. 54 kilometers is 54,000 meters. Divide that by 1 hour, which is 3,600 seconds, and calculating that gives us 15 meters per second. Now we need to find the braking distance, which is, so we've got the following information. U, the initial speed, is 15 meters per second. V is the final speed, which is 0 as we're bringing the car to a stop. The acceleration is negative 8 meters per second squared, and we want to find the distance that that whole process takes. We've got U, V, A, we want S, so the equation that we need to use is V squared is U squared plus 2AS. And we want to make S the subject, so we need to rearrange. If we subtract U squared from both sides, we get V squared minus U squared equals 2AS, which we can divide by 2A to get S. So S is going to be V, which is 0, minus U, which is going to be 15 squared, divided by 2 times negative 8. And if we calculate that, we get 14.06 meters. Okay, so that's part A. Part B, after a 40-second wait, the light turns green. It accelerates, the car accelerates at 10 meters per second squared. Find how long it takes the car to reach 54 kilometers per hour. So again, we're dealing with 15 meters per second. The car is coming up to speed, so it's accelerating again after the light turns green. So this will now be the final speed, and it was at rest while waiting for the light to turn green. So we've got an initial speed of 0, and the car accelerates at 10 meters per second squared. And first thing we need to find is the time. We've got V, U and A, we want T, so the kinematic equation of motion to use is V equals U plus AT, which means T if we rearrange that. Firstly, subtracting U from both sides, we get V minus U equals AT, and we divide that by A. V here is 15 and U is 0, A is 10, and we get 1.5 seconds. We also need to find the distance that the car travels while accelerating. So that's going to be, we have A, U and V, we want S, so that's in the same situation as part A. We're using V squared equals U squared plus 2AS. We're solving for S, so we've got S equals V squared minus U squared over 2A, the same rearrangement that we had in part A. So here we've got V is 15, and that's squared minus U, which is 0, divided by 2 multiplied by A is 10, and that gives us 15 squared is 225, divided by 20 gives you 11.25 meters. So we have the distance that the car covered while accelerating. Part C of the question, find the average speed of the car during the entire process. So the average speed, VAV, is equal to the total distance covered in the entire process divided by how long it took. Average speed is total distance divided by total time. Okay, so we need to find the time it took the car to decelerate, since we haven't got that yet. So that is going to be, we're looking for a time, and we know the initial and final speed and the acceleration, so again we're using t equals v minus u divided by a. We're looking at the deceleration, so the final speed is 0, initial is 15 divided by a, which is negative 8, and that gives us 1.875 seconds. So the total distance will be the distance covered while decelerating, while slowing down after the light turned red, which is 15.06 metres, plus the distance covered while accelerating back up to 54 metres per second once it turned green, which is 11.25 metres. That's the total distance, and we need to divide that by the total time, which is the time it took to decelerate, is 1.875 seconds. Then you had the 40-second wait, and then you had 1.5 seconds to get back up to speed, and if you calculate that, you get 0.58 meters per second. Okay, now question D, which is, if the light stayed green and the driver could maintain a constant speed of 54 kilometers per hour, how long would it have taken to cover the distance it covered while accelerating and decelerating? So we're dealing with constant speed. We're thinking about what would have happened if the light had never turned red and they could maintain a speed of 15 meters per second all the way through. So constant speed means d equals vt, and we are trying to find the time here. So that means time equals the distance divided by the speed. So the distance will be that total distance covered, which is 14.06 plus 11.25, which is 25.31, divided by the speed is 15. Calculating that gives us 1.687 seconds, which is how long it would have taken them to travel that 25.31 metres at a constant speed if the light had not turned red there. And part E of the question, we need to find how long the driver lost due to the lights turning red. Okay, so the amount of time the driver lost would be the total amount of time that the whole process took minus what it would have taken if the light had stayed green. So the time taken would be, so the time lost would be time taken minus that 1.687 seconds that it would have taken if the light had stayed green for the duration. So the time taken is, there was that 1.875 seconds that it took for the car to slow down when the light turned red, plus the 40-second wait, plus the 1.5 seconds to get back up to speed, minus 1.687 seconds, giving you 41.7 seconds. So the 40-second wait while the car was stationary, plus a little bit more time due to the fact that the car would have covered that 25 metres at a speed slower than 15 metres per second, and therefore would have taken longer to cover that distance. Thanks for watching. Over and out.